So here we are on to 12c. Now we're looking at water coming out the end of a hose pipe. The question is telling us that air resistance has negligible effect on the motion of the water, and the water jet reaches a maximum height at point Y. So the first part we're looking to do is we want to see what's going to be the direction of the force acting on the water at Y. Well, as the water exits from X, moves up to Y, and then starts coming down again towards Z, the only force acting is the weight of the water, and the weight of the water, of course, will be acting straight downwards at every single point along the water's trajectory. So the answer we want here is vertically downwards. Okay, let's move on to part 2. Now what we have to do here is we've got to describe and explain how the horizontal component of the velocity of the water varies from point X to point Y. Now if we go back to part 1, we can see that the only force acting on our object is vertically downwards, and it's doing that all the way through there, and because it's vertically downwards, it has got no component in the horizontal direction. So, describe how the horizontal component changes. We would say the horizontal component of velocity doesn't change. Now we've got to come on to explain why the horizontal component doesn't change. There were a lot of answers who said because it doesn't accelerate in the horizontal direction. Well, that's actually part of the state, because if the horizontal component of the velocity doesn't change, saying it doesn't accelerate is just another way of saying this. But what we need to do is we've got to explain why the horizontal component of the velocity doesn't change, and we would do that because there is no component of the force in the horizontal direction. Okay, now let's move on to part 3. Describe how the vertical component of the velocity of the water varies from point X to point Z. So if we go back to our graph here. Now, if I'm going to change the colour, because now we're dealing with the velocity vector. Let's go to green. At point X, the velocity vector is pointing upwards of the vertical component. At Y, which is the maximum height, there is no vertical velocity vector, and at point Z, the velocity is now going to be acting in the downwards direction. So, students coming past, hope you can't hear them. If we have a look at this, if I do it on this page, I'll just get the pen. There we go. If we were to have a look at what's happening to the velocity, let's do it as a velocity against time graph. At point X, it's moving upwards, and then it would be accelerating or decelerating, slowing down to point Y, where it comes to a stop, and then it changes direction and comes back to, and is falling downwards at point Z. So here again we're only describing, we're not having to explain how the vertical component of the velocity varies. So what we would say is if you have a diagram drawn, this would help you with your how you're wording your answer. And I would say that between x and y, the velocity is slowing down, or the velocity is getting smaller. Is decreasing. I would say the special case is at y, the velocity, or the vertical velocity, I should say, is 0, and bullet point these bits, and at point, and then then I would go between y and z, the vertical velocity is increasing. Now there's lots of bits you could do, because you could argue, well, it's constantly decreasing because it's decreasing from a positive value to 0 going into a negative value. But I think if you've got the graph drawn in, either way of how you're trying to describe it, you're not going to be able to muddle the two different ones where we're saying it's increasing and it's decreasing, or if you were constantly saying it was decreasing but it's changing direction, then just having the graph, drawing a sketch, is going to help you out every single time.